Did you guys find the free response rubrics all right? Anybody have trouble finding that? Okay. Did you look for it? Okay. The question had to be asked. All right. If you need help, you can pull out your laptop later. I can take a look. All right. I think this class we went over number 22, correct? Was that the last one we did? Did we finish it? Any questions after going over that? I think we finished that one like as the bell was ringing or close to it. All right. That was 22. 24 was the next problem. No. Yeah, 24 was the next problem, and only 34% got it right. That's pretty good.
Did we guess? Yeah, we did. We put a question. Not really guess. Oh, yeah, we guessed.
All right. Again, as you move through, guys, I'm going to try to help you, guide you through this. This is your first experience. Did you notice that the problems got more difficult as you got towards the end of each section? All right. So this is a heavy conceptual question, but it also takes the skills of what derivative rules are applicable here. So let g be the function x squared times e to the kx, where k is a constant. For what value of k does g have a critical point at 2/3? All right, so interpret that. G will have a critical point when g prime equals 0. So they're telling us g has a critical point at 2/3. G prime of 2/3 must Do you know what g prime of 2/3 must equal? 0. You understand that? Now, there's some work to be done here. We better find g prime of x. Well, what is the appropriate derivative rule here? X squared times e to the kx. Product rule. Good. First, the derivative of the second is e to the kx times k. Do you agree with that? E to the kx times k. If it was e to the 5x, it would be e to the 5x times 5. So e to the kx times k. Plus the second times the derivative of the first, which is just 2x. Two terms. G prime of x. I'm going to write it out front. K x squared e to the kx plus 2x e to the kx. All right. And I know g prime is going to equal 0. Now, you have some choices here. G prime of x equals 0. Now, to save us some time, help me out. How many of you made it this far? Raise your hand. You made it that far. Okay, the rest of you. Did a derivative rule derail you? Product rule derail you. Those of you who missed it. It's okay, own it. Those of you who missed it, did a product rule or some derivative rule derail you? Chain rule? Okay. Mark that down, all right? Make notes. If you missed the product rule or chain rule, if you forgot the k, if you did e to the kx and didn't put times k, that's a chain rule issue. If you didn't even recognize the product rule, obviously it's a product rule issue. All right, make notes. I can't help you unless you try to help yourself. For those of you who made it this far, did you plug in 2/3 for x at this point? Or did you solve for k and then plug in 2/3? Help me out. How many of you plugged in 2/3 at this point? That's probably a non-traditional process for you. You guys were conditioned over the years. Solve for the variable, then plug in numbers, right? Solve for So I get it if you didn't do that. That's fine. It's just going to be more abstract. How many of you that made it this far just solved for K? Nobody. Okay, so I'll go ahead and plug in 2/3. Does everybody understand why we're plugging in 2/3 right now? The derivative equals 0, and we know 2/3 plugged in for x will make the derivative 0. All right, so I'm plugging in 2/3 for x, and that's what I get. Nope. My bad. Hold on. I plugged it in for k. So there's a bunch of. I need to stop. There's a bunch of things going in my head. Yeah, kids taking retakes. I'm hearing the noise. I'm trying to think about what they're being disrupted. All right. So I'm plugging in 2/3 for x. Sorry about that. So I have k. I plugged in 2/3 for x there. I need to plug in 2/3 for x there. 2/3 k, and then 2/3 k. Everybody good with? Everybody with me? What would you do now? What would you guys do? Cole?
Divide by e to the 2/3 k because it's in both factors.
What do you mean by divide?
Divide it out of both sides of the equation because it's not relevant anymore.
When you say both sides, you don't mean this.
Yeah, I mean the 0 and the
Both sides of the literally
both sides of the equation. Yeah.
Is that legal 100% of the time, or most of the time, or some of the time? Not at 100, close to 100%.
Some of the time.
Can you divide by e to the 2/3 k? Or do we not know? Can I do a quick review with you guys? Because you've told me in the past you struggle with factoring. Yes? It's time to play a little game called Legal or Illegal. We have factored some polynomial and gotten to this point. What polynomial was it? Yes? What would you do here? Set them both equal to 0. You have a product of two quantities. Two things are being multiplied. Their product equals 0. If you were never told this in the past, I'm telling you now. You have a product. This is why you do this process. You have a product of two quantities. The product equals 0. What are the possible situations? Either x equals 0. Wouldn't 0 times something equal 0? Or x minus 4 equals 0, because 0 times this thing will equal 0. Or both equal 0. One of them 0, the other one 0, or both are 0, correct? So we're going to set both of them equal to 0 to see if they have solutions. So that's why we set x equal to 0 and x minus 4 equal to 0. And we get 0 and we get 4. Do you agree? 0 and 4 are correct solutions. Rewind. Another student comes along and they say, well, I'm just going to divide both sides by x. X minus 4 equals, okay, 0 divided by x, 0. X equals 4. What broke down in their logic? Have you ever been taught this? You remember saying this? Why? This is illegal. Oh, I ruined the game for you. The game was called Legal or Illegal. Spoiler.
Illegal.
It is. Yeah. You all win. Why? Why? Someone other than Cole. Cole with his fancy K.
Try to eliminate K.
Cole, are you jealous? Do you wish yours was with a K?
Oh, it's kind of cool.
It's cool. It's
Well, credit where credit's due.
pretty hip and trendy. I saw a hand over here.
It was lame.
Wendy.
Oh, Wendy.
Wait, hold on.
I gotta take it. Because it's always gonna be 0.
What's always going to say?
X.
What do you mean by that?
Like it just cancels out X minus 4.
Yeah, right. So what's the problem? I'm with you. I think you're right.
No, you just can't do that.
Don't get sassy when I was trying to be credited. All joking aside, why is this student's work wrong? I mean, they justified it. They said I divided both sides by x. Cancel. 0 divided by x, 0. That's solid math, isn't it? Or is it?
X is 0.
Huh?
What if X
What if x is
is
0?
Oh.
You're saying 0 divided by 0 is 0? No. And guess what just happened? When you divide by x, even if you don't realize you're doing this, if you divide by x, you're saying my division is legal. If you divide by x, you're saying I'm allowed to divide by x. I just did it. What are you not allowing to happen? You're not allowing x to possibly be 0. Would this work for any other number other than 0? Yeah, if x were 10, legal. But if you divide by x, you're saying I'm not dividing by 0. Are you with me? So you have eliminated a possible solution by doing that. That's not okay. And what did we find out? X equals 0 was a solution, wasn't it? You just eliminated it and you only got one solution. That's kind of interesting, isn't it? So back to the story. I love storytelling. Math storytelling. I feel like we should have carpet squares and just like sit around in a circle, talk, have little snacks, maybe like animal crackers. Not the terrible kind, like the iced ones.
What's so terrible?
What do you mean the terrible kind?
Yeah, that's all right.
The bland ones?
Yeah. What?
They're
Those are
not
crazy.
It's like tasting
The ice
cardboard
ones,
with
you
a
can have
little
like
bit of
5
sugar
of them
sprinkled
before
on it.
they're
Huh?
That is
Your mouth gets so dry.
No, the iced ones. You can have like 5 of them before they taste like
pretzel.
just gross.
Yeah, they get kind of that slime
Yeah.
to them.
Not
Cuts
the
your mouth.
They're just tasty.
Kind of pasty. You get like a paste to them. We're doing good work today, friends. All right, let's get going. All right,
It's toxic.
Cole with a K.
Good guy.
The good kind. No offense. Suggests we divide by e. Did you say just e to the 2/3 K?
Yeah.
Legal or illegal?
I'm saying illegal. I'm sticking to it. I don't care what you say.
Even if you don't have the beard, it's worth it right now.
I have to do that.
Oh no, it's illegal.
Nah,
it's legal.
Madison, what are you thinking? I heard you
Oh,
say
it's
something.
legal. Yeah, you can't ever make 0. It's legal. You can't.
Just feels wrong.
You're never gonna multiply by
Feels
0.
wrong, but maybe that's
It's legal. Gotta be legal.
Feels wrong. Feels kind of like eating regular animal crackers and you have an iced animal cracker option. I'm wasting a ton of time here. Okay.
It's legal.
Can e to the K, 2/3 K equal 0? E to the 2/3 K. E to the 2/3 K never equals 0. So are you allowed to divide by it on both sides? Yes, you could. I would be a little nervous. Might even feel a little guilty about doing it, have regrets later. But it is legal. It's kind of like turning left on a one-way street, like on a red light. It feels illegal. But if you're going from one-way street to another one-way street, you're allowed to turn left on a red. It's legal. Perfect analogy. Had that one in my back pocket for a while. All right. What's the safe thing to do? Wait for the light to turn green. No. Factor out e to the 2/3 k. What's left inside? 4/9 k plus 4/3. Are you with me? So Cole is not wrong, but this is the safe bet. Factor out an e to the 2/3 k. Guess what I have? Two factors multiplied together that equal 0. What is the safe thing to do? Set them both equal to 0. And this, you still have to address this issue. Can e to the 2/3 k ever equal 0? Do you know what? You guys know it's an exponential function, right? And it's not translated up or down. Oh, that's my sweet niece. I bet she brought me dessert. She's a big one.
Yes, adorable. Would you like a cookie?
I love cookies. Did you make them?
I did. You can have a whole one.
Thank you. I wanted that. That's a stupid rule. All right. Ready to solve for k? Multiply by 9/4. That feels wrong?
Yeah, a little bit.
I got -3. Is that right? It's a fun problem right there. What do you guys think?
So, when it's like the 0 equals and then k times 4/3 or 4/9 e to 2/3 of k, like that long one, before you factored it out. I just subtracted over one of those terms and then divided by e to 2/3 k.
Same as what Cole was saying.
So it only works because it just can't equal 0.
Be careful. Legal in this case, but not always. That's kind of tricky, wasn't it? Was 27 the next one? You guys did really well on 27. Surprisingly. Just kidding. All right, 28 was a wreck. All right, let me run through it quickly because I wasted a lot of time with the story and the game that wasn't really a game. I apologize. I have a lot of guilt. About my teaching style. I apologize.
It's fun. Yeah, that's one of my favorite
Engaging.
apologize.
I'm glad some people like that. Because I watch other math teachers and I'm like, oh man, they're so like on topic and concise.
Yeah, they're on time. Sometimes they're paying attention.
Yeah.
You've been eating that cookie for like 5 minutes. It's making me hungry.
It's because you let him have the whole cookie.
Was
there like
Is it chewy or crunchy?
I don't know if she meant to pick the whole thing. Like I was gonna take half of it. All right. The position of a particle moving along the x-axis is given by this. So position. What is the acceleration? Okay, so you should be thinking x of t, v of t, a of t. We always go that direction. What is the acceleration of the particle at the point where the velocity is first equal to 0? Do you see the layers to the question? You're going to have to find an acceleration, but you're going to have to find the time when the velocity first equaled 0. Does that make any sense? So what's our process? Who can verbalize this for me? I can't. I'm eating a cookie. Cole.
You have to find the derivative of the position equation first. I'm still going. Okay. I didn't think that far ahead. And you said it equals 0.
Very good. Good job, Kylie. Find the time. Find the time when the velocity first equaled 0, and then plug that into acceleration. I want to know the acceleration. Ready? Velocity. Cosine t plus sine t. Set it equal to 0. Now, without a calculator, eyeballs up here. Without a calculator, that's tough to solve. So what should you be thinking of? This is the way I thought of it. When does sine of t equal negative cosine of t? When is the y value in the unit circle equal to opposite its x value? Or equal to the same value as opposite for cosine, which is the x value, right? Do you agree it's the 3 pi over 4? Is sine positive there? What's the sine of 3 pi over 4? Radical 2 over 2. What's the cosine of 3 pi over 4? Negative radical 2 over 2. Does it match that rule? Yes. So the answer to that, the time, is 3 pi over 4. Then you have to plug in 3 pi over 4 in for t in the acceleration. Well, we have to take the derivative of velocity to get acceleration. Negative sine of t plus cosine of t. Plug it in. I think I got negative radical 2. Again, I don't know what's going through your head right now, other than maybe what you're eating for lunch. But man, that cookie looked good. But the first thing you should be thinking of is, man, that was tough. But I bet if I saw one like it, I could at least get. If I didn't get it, I could get a lot closer than I did the first time. That's your goal right now. Chip away at the hard outer shell of some of these problems, and just try to get closer to the solution. Each time we do these, you'll get closer, and you'll probably start getting these kind of right. Make sense? All right, to the calculator active portion. Something I want to address that comes up every year. I want you to read number 3 down here. All right, have you seen that before? Have you heard of arc sine of x? Do you know it's the same thing as sine inverse of x? So what if they say find the derivative of sine inverse of x squared? One over square root 1 minus u squared times that, right? So what if they ask? Find the derivative. Of arc sine of 2x. Same thing. All right, that's what they're trying to tell you. If they write out arc sine, think of it as sine inverse, right? 76, you guys nailed it. You guys did awesome on this. Here's what I will say. This type of problem is all over the newer AP tests that I've seen. I call this the visual first derivative test-ish. They'll give you variations of it, okay? Listen carefully. What are you looking at right now? The graph of f. A lot of times they will show you the graph of f prime and ask you about f. Well, when not this problem, if f prime is positive, f must have been increasing. If f prime crosses through the x-axis, positive to negative. If f prime crosses through the x-axis, positive to negative, f must have had a maximum value at that x-intercept. That's the kind of thing they're going to ask. All right, you guys did well. We're not going to talk about it. All right, 77. You guys did awesome. 78. All right, 42%. All right, the graph. The graph of y equals e to the tangent of x minus 2 crosses the x-axis at one point. Is that where the derivative equals 0 or where the function equals 0? The graph of y equals e to the tangent of x minus 2 crosses the axis at one point. That's where the function y, not dy dx, y equals 0. Continue reading. What is the slope of the graph at this point? Plan, set y equal to 0, solve for x, take that x and plug it into the derivative. Can you interpret that? You guys okay with that? Find the slope at that point. Derivative at that x value. All right. E to the tangent of x minus 2 equals 0. Do you not? Oh, calculator allowed. I almost blanked out and forgot. Calculator allowed. Okay. I'm probably going to regret doing this in the calculator window. Here's just from experience. Here's what's going to happen. All right. Prediction. E to the tangent of x minus 2 equals 0. Because it's e to a trigonometric function, there may be multiple times where it equals 0. Okay. We're going to look at the one from 0 to 1. So we're still going to do it this way, and I'm going to kind of show you maybe second thought. Okay. Menu, algebra, solve. E to the tangent x. I need to arrow over one more time to get back down. There we go. Is it minus 2? Yes? Equals is right here next to the underneath the control. Equals 0, comma, down here to the left, x. Enter. All right, that's not, well, yeah, that's what I expect. What does the n1 mean? n1 pi plus tangent inverse of ln 2. If I hit control, enter. 3 point pi, okay. Pi times n2 plus that decimal. What does that mean? It's giving me a function to find every iteration of where this happens. Does that make sense? It's going to happen infinitely many times because it's a trig function. It's going to repeat. And that wasn't very nice. Let's graph e to the tangent of x minus 2. So graph. E to the tangent x minus 2. We only need to see from 0 to 1. So I'm looking at this guy right here. Okay. So I'm probably going to even change my menu. Menu, window, settings. We'll go from 0 to like 1.5. There she was. All right, menu, trace, graph trace, arrow, arrow. Thank you. 0.606. I'm probably going to take that decimal further. Okay, 0.6061. X equals 0.6061. Did you need a pass?
No.
Okay. All right. Is that my answer? Ooh, they want to trick me into it, don't they? See? Oh, look, it's tempting. It's right there. I want to find the slope at that point. I really want to find y prime of 0.6061. All right. So, a couple ways to do that. I could graph the derivative. Okay, I'm going to show you guys a little trick. I don't really want to do this on a graph. Would you guys agree it'd be easier in the calculator window? Take the derivative, plug in 0.606. Yes? Okay. I've already graphed it. I don't want to waste the time typing it in again. My graph, my calculator, it's called F1. I'm going to go back here. Okay. I'm going to do the derivative. I'm going to show you a new feature right now. All right. I could take the derivative, get a function of x, and then plug in 0.606. That's one option. Another one is menu calculus. Derivative at a point. Here's what it's going to ask me. What's your variable, x? What's the value? It is a fun game. 0.6061. First derivative. Okay. Now it's going to ask me the function. Well, what was mine called again? F1. Anywhere in my calculator, it recognizes the f1 of x function as e to the tangent of x minus 2. So I go to my variables. The only one I've typed in, the only one I've graphed. If you have like 5 graphs open, you'll have like 5 options right here. Okay? F1 of x. Now, could I type it in again to be sure? Yes. All right. That's ugly. Decimal 2.961. Is that an option? 2.961 is an option. You follow that? I'm trying to show you some calculator tricks. I'm working on options for calculators. I'm talking to Mr. Harold about options. Okay, what could we do to make sure you're not stressed out that your calculator is going to die in a few months? All right, working on it. Did you at least follow along and understand that process? Just some tips and tricks as you go. All right, that was 78. 79. What was 79? I shouldn't have asked this, to be honest. You know what I did? I read the question. I'm like, velocity, acceleration. And then I forgot there's integral symbols there. It's integral symbol. Yes. Right, Tyler? Right, Tyler? You having a rough week? Tyler, you having a rough week?
I'm so tired.
These 3 days are just rough. What's going on, man? What's with the umbrella? What's with the umbrella? You afraid it's going to rain today?
Just making sure.
You never know. What's going on? Do you need to talk a little bit?
Nah.
Up late last night?
There's nothing to talk about, really. I mean,
Are you working? Like, what's going on?
yeah, we're 5 days a week.
Where are you working?
Grinders.
Oh yeah. I never see one there.
I'm usually back
In the back,
in the kitchen.
prepping food.
Prepping food in the morning, and then at night, when I do have morning shifts, at night, then I'll just be grilling.
I worry about you.
Smiling.
I don't know. I'm picturing you just back there growing up. I want to imagine you have like an apron on that says like something about being like kissing the
Grill
chef.
master.
Yeah, you see your grill. You see your grill. It's terrible. Like, it's embarrassing. You want to hear it?
You didn't tell us inappropriate.
Oh yeah, that's kind of messed up. We're adults. I work 5 days a week. I can hear a joke.
The question was like a pickup line. It was like, "Are you free tomorrow?" And I said, "No, I'm expensive." No, it wasn't that one. No, it was an alcohol joke. It was a chemistry joke. Something about alcohol always being the solution. That's kind of inappropriate. Alcohol is never the solution, friends. But in chemistry, is it a solution? Maybe Tessa knows. Okay. Hi, Tessa. You need to pass me anything?
No.
You guys? You're right, Linda.
You called her chemistry.
Have a good day, Tessa. I don't blame her, but no, Tessa. You hate me too, Tessa? I called her chemistry. Was that a chemistry joke? Did you say no reaction? Is it alright, Tony? Anyway, I don't know why you guys missed that one.
Yeah, he's like chemistry. You went so fast. And you're gonna say that she hates you. It's like, well, I don't know why. You just call her chemistry.
I should probably stop recording. It's like the student, you know, like when you pass them in the hallway and like they like make up on purpose, try to find something to do to not look at you. Like, you do that? I'm starting to regret some life decisions. All right, 80. This one is rough.
Yeah.
We should probably end with this one. Things are falling apart. Huh? Oh, you guys need a joke. Yeah, sorry.
That was the joke.
That was the joke. Call her chemistry. She's out of her element.
That was bad.
This is terrible. Did you adopt your dog? No, he's my biological dog.
Yeah, it's just sarcastic.
It's a rough one.
It's like
Rough fucking dog.
All right, the graph of f prime. The graph of f prime, the derivative of the function f is shown above. As soon as I think this, as soon as I read this, I'm thinking f prime, f prime. What's happening on this interval? From left to right, f, if f prime is Nope. Negative.
Or if f prime is negative.
If f prime is negative, f must be decreasing. F prime is positive. F prime is positive. Do you all agree the f primes are positive from here to here? Don't let your eyes get tricked. But the graph's going up and then going. No, this is f prime. It's above the x-axis. F prime's positive. F is increasing. After this point, f must be decreasing. Okay? Then we kind of think through what else are they going to ask us. Does f have a relative max at... Okay, I didn't see the negative. Negative 3. I'm like, 3? It's over there. All right, at negative 1, 2, 3. Negative 3. F prime changes from negative to positive. F has a max or min? Min. Do you agree? Yes? All right, now we're on to points of inflection. That's asking about the points of inflection. Second derivative. Now we're changing our thought process. We're not looking at positive, negative anymore. Now, if we're thinking about f double prime, we're looking at the slopes of this graph. Aren't the slopes of the f prime graph f double prime? Does that make any? Are you guys with me? Right. Won't f have a point of inflection when f double prime changes sign? F double prime changes sign. Yes? Describe, what are we looking for in this graph where f double prime will change sign? I heard someone say it. Slopes. Is that Casey? No? Kylie? Did you know, or just kind of?
I said slope.
Slopes what? The slopes of this graph?
The signs of the slope.
Yeah. Looking at the signs, right? Ready? What's the slope of f prime here? Positive. I can't tell if it's 0 there or not. Doesn't really matter. Still positive. Then f prime's slopes change from positive to 0 to negative. What's happening there? What did f double prime do? Changed. All right, if you ever forget, I want to, this is so important. I cannot emphasize how important this question is, okay? Kind of unfortunate that we got so sidetracked today. I don't know whose fault that is. But pull it back here. We'll pull it back here for the last few minutes, all right? If you ever get lost, try to lay it out how we've practiced it all year, okay? If you're looking for a point of inflection, isn't that where the signs of f double prime change? So this is not this graph, but let's just say f double prime is positive and then negative. Positive and then negative. F prime must have been increasing and then decreasing. So what am I looking for? If I'm looking at the f prime graph, that's here. I'm looking for increasing and decreasing, or decreasing and increasing. Yes? Do you agree? I'm looking for a change in direction on f prime. A change in direction, aren't I? Does f have a point of inflection at -2? In other words, does f prime change direction? No. The graph of f is concave down from 0 to 1, 2, 3, 4. Well, f is going to be concave down when f double prime is negative. F double prime will be negative when f prime is decreasing. This is the graph we're looking at, f prime. Is f prime decreasing the whole time from 0 to 4? Yes. Is it 1 and 3? Is it E? What number is this? 80? Is E? Yeah. Does that make sense? Don't just like challenge yourself to never write anything down on this kind of problem. If you just narrow it down, like look at the process, look at what layer you're supposed to be analyzing, and go to that layer and think it through. All right? I'm not giving you guys homework. Enjoy your weekend. Oh yeah. Yeah, if you haven't done it yet, you want to do your velocity activity, your driving activity, that will be due Monday. All you have to do is record the speed. I should probably delete the video. Of course.